Hey guys, today let's solve the symmetric tree problem. So, this is the given problem, right? They are giving us the root of binary tree. What we need to do is to check either the binary tree is a symmetric tree or mirroring tree. Well, what does it mean? Let's take a look at the example 1. Let's say the given input is like this. Is it a mirroring tree? Yes. They have the same node values and the left and right having the same structure, right? Then what if the example 2? It's false. Why? Because the structure are not mirroring each other, right? If the given input is 1, 2, 2, null 3, and 3 null, like the picture below, it will show true. Well, then they ask us to solve it both recursively and iteratively, right? So, basically we can solve it using DFS iteration with one step or DFS recursion. Then the last one, we also can solve it using BFS. The main thing is that symmetric tree should have mirroring structure and same node values, right? That means if one of them is null, we return false. If both of them is null, we continue, right? And another thing is that if the value are not equal, return false. Okay? So, let me show you how to solve it using DFS iteration with one step. First, if the root is null, return true. Then create step, then push the root.left and root.right to the stack, because we are checking the mirroring tree. Then while stack is not empty, this one is return true for final decision after checking inside while loop. Get the left node and right node from the step and call them as P and Q. If both of them is null, we just simply continue, right? If one of them is null or value are not equal, return false. Then the last one is step push p.left and q.right. Step push p.right and q.left. Because this is mirroring, right? So we check the left right and right left to check the mirroring. Let me show you. Let's say the given input is like this. So at first the step will be root.left and root.right, which is 2 and 2, right? One step is not empty, cons P and Q, right? Then step is last in first out, so we will not use for because step is leave for. Now the step is empty list. Is 2 are not equal to 2, false, continue. State.push p.left q.right, which is state.push p.left is null. Then q.right is 3, right? then state dot push p dot right, q dot leave, which means p dot right is 3, then q dot leave is null. Now the state we have null and 3 and 3 and null. That's all, right? Then while state is not empty, we get the p and q again from the state. State dot top. Because state is leave for, right? Last in first out, so we only leave null and 3. Is 3 are not equal to null? True. So return false. That's all, right? Let's turn them into code. Cons symmetric tree we need to create a base case here to handle if the root is null. So if root is null, return true. Then the state is empty list, state dot push, root dot leave, root dot right. While stack dot length is bigger than 0, because that is last in first out. Then we're gonna check, right? If both of them is null, we continue. Then if one of them is null or the value is not equal, return false. State dot push, p dot leave, and q dot right, because this is mirroring, right? State dot push, p dot right, and q dot leave. Check the mirroring tree. Okay, then we need to return true. Final decision after checking. That's all, right? Let's do the time and space complexity analysis. This one is O in space. O1 time per all. Overall is O(n) time. Check the mirroring children. Then this one is O(1) time per push. Overall is O(n) time. This one will be same. Then this is O(1) time. While for this is O(n) time. So for the option 1, it will be O(n) time and O(n) space. That's it, right? For iteration solution. Let's move to option 2. DFS recursion. If the root is null, return true. Create new function is symmetry to check the mirroring child node. Then return recursively check from the left and right root. Inside of here, if the p and q is null, return true. If one of them is null or the value are not equal, return false. Then we return recursively check the child node leave right and right leave. That's it, right? Let's say the given input is like this. That means the root is 1, 2, then null, 3, null. At first, we're gonna call is symmetry, root.leave, and root.right, which means we call is symmetry not true and not true, right? Then on here we're gonna call not true.leave, which is null, and not true.right. This one, right? Not true.right is 3. No 3. Then we're gonna call symmetry not true.right, which is 3 on here. Then not true.leave, which is not true.right is 3. Then not true.leave is sorry, this one should be null. Then not true.leave is not 3, right? So this one will be return true. Well, for this it will be called is symmetry not true.leave, which is null, and not true.right, which is null as well. This will be same. I will just copy it. Both of them is return true. So for this, it will be return true. Overall, because all of them is true, we gonna return true. That's it, right? Let's turn them into code. The best case is if the root is null, return true. Then cons is symmetry P and Q. If both of them is null, return true. If one of them is null, or the value are not equal, return false. Recursively check child node mirroring, which is leave right and right leave. P dot right and Q dot leave. Then return, we starting checking from the root right is symmetry root dot leave and root dot right. That's all. Let's do the time space complexity analysis. This one is all one time. Then overall, this is all in time and all n space due to recursion using stack. That's all. So this will be point time and or and space. Do it through recursion using step. That's it. Then let's move to option 3, BFS. If the root is null, return true to the queue, then push the left and right node of the root to the queue. The queue is not empty, then we return true for final decision after check. Get the left and right node from the queue. If one of them is null or the value is not equal, return false. Then if both of them is null, just continue. Queue push the child node mirroring into the queue. Queue push the child node mirroring. Leave right and right leave. I think this all. Okay. Well, let's say the given input is like this. So at first, the queue will have not 2 and not 2. While queue is not empty, queue is first in first out, so we're gonna use shift because queue is before. Now the queue is empty list, right? So is 2 are not equal to 2, false, continue. Queue the push, P the leave, Q the right. P the right, Q the leave. P dot leave at here is not 3. Q dot right is not 3. Q dot push, P dot right is not 4. Q dot leave is not 4. That's it, right? So now the queue we have not 3 and not 3 on index 0. Then we have not 4 and not 4 on index 1. While queue is not empty, I will just copy this. V4, so we're gonna leave the not 4. Then this one is not 3. Is 3 are not equal to 3, false, so we just continue. Then because 3 doesn't have any child node, right, we just continue the checking. It will get again. While queue is not empty, we get the 4. So now the queue is empty list, right? This one is not 4. Is 4 are not equal to 4, false. So we just exit. While loop, then return true. That's it, right? Let's turn them into code. If the root is null, we return true. Let queue is empty list and I'm gonna push them to the right. while q dot length is bigger than 0, we're gonna get the not right from the q. Q is first in first out because q is 50. If both of them is null, we just continue. If one of them is null, or the value are not equal, q the false. Return false. Then checking the mirroring child node. Left right and right left. Q dot push, P dot left and Q dot right. This will be same. I will just copy it. Then this one is right and left. That's it. And we return true. This one is final decision after checking. That's all. Let's do the time space complexity analysis on time. Purpose overall is or in time. This one will be same. Then for this, mirror for this is all in time because we need to visit all nodes at least once. Or in space, on space, on time. Yep, it's all. So for BFS, all in time and all in space. That's all. Let's try them, right? Which one that we want to try? Let's try option 1. BFS iteration. Pattern 2, then let's take is root dot left, root dot right. Const that the length is bigger than 0. Const p q is state dot op because that is before. If symmetric tree need to have the same value and mirroring structure. So if one of them is null or the value are not equal, return false. If both of them is null, continue or return true. No, we still need to do the checking, so we just continue. If one of them is null or the value are not equal, we return false. Step push, p dot left, q dot right. Step push, p dot right, q dot left. On time. This will be the same for here. Checking the mirroring child node. Left right and right left. this one is O1 space and this one is ON time. Because we need to visit our nodes at least once. That's it, right? So overall is ON time and ON space. Okay, it's working. Let's move to option 2. Option 2 is DFS recursion with one step. Then check tree P and Q. If both of them is null, return true. Then if one of them is null or the value are not equal, return false. Leave right and right leave. Return check tree P dot leave Q dot right and check tree P dot right Q dot leave. This one is check tree root dot leave and root dot right. In space due to recursion using state. So overall is O in time and O in space. Okay, it's working too for option 2, right? Let's move to option 3. Option 3 is BFS. Well, so we need to create a queue. We're gonna start from the left and right. Well, queue dot length is bigger than 0. Get the current node right from the queue. Queue is first in first out because Q is V4. If both of them is null, continue. Then if one of them is null or the value are not equal, return false. Then Q push P dot leave Q dot right. Q push P dot right Q dot leave. Return true. Final decision after checking this one is O1 time. Checking the mirroring right node, which is left right and right if O1 time per push overall is O n time. Then this one is O in space, O in time. Time conceive overall is O n time. That's it. So for this will be O in time and O in space. Let's try them, right? Let's try to run them. Cannot access queue. I think I have queue, right? Yes. Okay, let's try to submit. It's working. I think like that's all from me. See you next time.